Join discord.gg/flatearth and enter a check-in room. Someone will come along and verify you to get involved in the conversation about our Earth.
Hey guys, mic check, mic check.
Yeah, Mike's fine. I'm fine too. So it's Quantum Eraser. We're all fine.
Hey Kiwi.
What's up? Oh, that's
Yeah, this
bad. I should never say that. Every time I fucking say that, people say the sky.
This is the Rebel.
Yeah. Oh, you got in a little pissing contest with Nathan. You fucked up.
yeah. I stirred up a pot a couple of weeks ago.
No, you
With
fucked
cheese.
up. You didn't stir up the pot. You just fucked up.
Was
Yeah,
that
I
with
did,
Matthew
I did.
Byrne?
It happens.
happened?
Yeah,
Oh,
with Matthew. Yeah.
it happens.
Yeah.
I remember that.
Fuck up.
Share your humility.
Yeah, no.
but you fuck up.
So yeah, I talked to in the after show to the guys. The confusion I guess I had was with trigonometry that I have applied to celestial navigation.
Oh, then Jedi is your man.
Yeah. Well, Adam actually jumped in right after because I listened back to it. And by the way, when I listened back to it, it didn't seem like I was clear as to what I was trying to say.
Gotcha.
Yeah. So and then I talked to Matthew Learns on the after show,
Oh god.
What?
and I basically, there's so many revelations from Matthew concerning his stance on it. Basically, it boils down to his beliefs.
Russ B.
Well, no,
yeah.
seriously.
Oh god, yeah.
He acknowledges that it's a belief. It's not provable.
It's worse than that. He doesn't know what a triangle is. It's well worse than that.
Yeah. But my question to you, well, I guess not a question. I'm trying to clarify that because I missed a lot of shows, as you know. But I'm trying to figure out celestial navigation from the standpoint of trigonometry. How? Because when I hear triangles, I think instinctively of trigonometry, right?
Yeah, don't do it.
Yeah. So that's the pit I fell into.
Yeah. Because celestial navigation has nothing. I reviewed every aspect of it, and if somebody could show me a trigonometric function in celestial navigation that they use, please, the floor is yours.
Well, you can't really use trigonometry
hold on.
because hold on. So because I realized one thing when I look at trigonometric functions, right? This is all two-dimensional graphs, right? If you look at the graphs in two-dimensional, like when looking at physical objects, right? You have to take into account perspective, right? And that's what trigonometry falls apart.
Yeah, well, see, you can use for terrestrial measurement. I went over this not directly, but indirectly on silly spinning space monkey arguments. And I brought up a point that I made many, many years ago. And Adam took it and ran with it. Because I was just thinking to myself those many, many years ago. And it was more in line with the angular diameter of the sun. Still with angles, but not with elevation angles. I digress. And I said to myself, is there a difference? Because what they say is, well, why does the angular size of the sun change, QE? Well, okay, well, fair enough, but you got a fucking problem, even with that blanket statement. Now, they're train wrecked anyway because it's been shown that the angular diameter of the sun actually does change in size. Back in 2016, Chris Van Maytrade did it. So besides that, I thought about it, the subject for a second, and I said, well, wait a second. Are we assuming anything here? You see, when angular size is brought up, those are terrestrial to terrestrial observations. Like if you see a fucking cow right, 10 feet away, or a bull, he's pretty damn big. But if I back away 300 meters, he gets small. Obviously, that's perspective, and that's angular size change with distance, obviously. However, when you try to superimpose that concept from terrestrial to terrestrial observations onto terrestrial to celestial observations, then you're in a fucking category error. It might sound for a second like it's a special pleading fallacy, but it's actually not. Because in order for you to superimpose the terrestrial to terrestrial observation onto terrestrial to celestial observations, you would have to fucking know what's between, not only what's between you and that celestial object and the makeup of that celestial object at a minimum. Follow?
Yeah, see, that's where I think probably the whole disconnect came from. That's not what I was talking about at all. So let me elaborate as briefly as I can. So when you look at, let's say, a piece of paper and you draw a 90-degree triangle, right? In a 90-degree trigonometric function, for the 45-degree angle alpha, for example, the tangent is the angle of the tangent and hypotenuse.
You're going to lose half the people in here. So you just got to sock a toe on a triangle.
No. I'm simplifying it. So at 45 degrees, your length of tangent should equal to the length of opposite. That's basically the function of 90-degree triangles, right? Trigonometric function. At 45 degrees.
Sock a toe.
Right.
Yeah.
Right. So, but that, however, does not apply to the phenomena of perspective.
Celestial
right?
objects. Correct.
Yeah.
Correct.
So you can't discern that angle looking at the elevation of the celestial objects.
You can discern the angle, but the elevation is, they even tell you, don't even try that shit. Don't try to get the opposite side because, number one, celestial navigators don't do it. Number two, it's nonsensical because what they...
Oh, it is nonsensical. That's right. That's what I was trying to get to.
Yeah, it's nonsensical to apply trigonometry in celestial navigation to angles. Yeah, it's a category error.
Well, not just celestial navigation, to really any situation that involves perspective.
Not terrestrial.
That's where
terrestrial. Well, then you start getting into. I can see what you're saying because whenever, I can remember in trigonometry, even though it was fucking decades ago, you're always given information on the sides and the angles. That information is given to you, like, for the height of a lighthouse, right? They always either give you the distance to the lighthouse or the height of the lighthouse.
That's
Follow?
Right.
Yeah, that's correct. They have to because you're stuck. You can't solve the right triangle without certain information.
Well, not only that, you can't solve the right triangle in terms of physical dimensions by looking at the objects. Because perspective, so, you know what I mean? Like, so trigonometry works
That's what
well.
I just said that. You need more than that.
Yeah, and so from that perspective of knowing about trigonometric functions of right angle triangles, intuitively you would say, okay, well, if we know at 45 degrees we're looking at the polar star, and we say, okay, that's the distance to it, to the GP.
To the GP.
Well, if we know the distance, right, then therefore we know the opposite, which is what 90-degree triangle function will tell you.
Right.
Except for the fact
except for the fact that if you move and let's say it's a 35-degree angle, then what does that tell you? Go ahead and finish the equation. Right?
No, that's not what I'm saying. So
Oh, for fuck's sake. I know what the fuck you're saying. Get to the point. What's the point?
well, I'm trying to
Everyone
get
else
to the point.
does.
What's the point?
Well, the point is 45 degrees in observation, right? The elevation angle does not equal 45 degrees on the 2D paper, is what I'm
What?
saying.
What? So, what? If you're talking about 45-degree, elevation angle to Polaris on? Well,
It's the same.
yeah, you're saying you can't do this on a flat piece of. I'm starting to get the kind of twinge for latitude lines. Sorry.
No, don't
Well,
worry about that.
not only that, the distances we're talking about 16 nautical miles per degree. That's a linear function, right?
Yes.
And which isn't true for trigonometry from ascertaining the length of tangent and opposite.
Well,
Okay,
the ball cards are screwed as soon as you say linear function, it's over. But that's another tangent.
That's right. Yeah.
no
So
pun intended.
linear function. Yeah, that's where it's over, really. And I was just going at it from a different avenue.
Am I wrong? Am I? Sorry.
Well, no, hold on. I just want to clarify something. So when
Yeah,
you say
please.
it's not the same as on a piece of paper, well, just so I understand what you're saying, is that measuring an angle by looking, right, by using like a sextant and looking through it and measuring that angle is not the same as changing that to an orthographic view of that angle.
That's right.
Okay.
That's right. So the very simple way to look at it is, if I draw a 90-degree triangle and I'll put the Polaris at the top of opposite, and I'll put you as an observer at the end of tangent, right?
Yeah.
And let's just imagine it's at the 45 degrees. Now, if I transport you like a computer graphic program from a 2D to a 3D without changing any of the positions at all, and I'll tell you what's the degree of elevation to the star you're looking at. Now, remember, you haven't changed the position. The Polaris hasn't changed the position. 45 degrees is not going to be what you're going to tell me.
I don't know about that, and maybe I'm missing this in translation. If you put a protractor on a piece of paper and you measure a 45-degree angle, and then you measure a 45-degree angle, it's the same fucking 45.
Well, that's what I'm saying. It's not going to be the 45 once you looking at it with perspective in mind.
Yeah, it is. Perspective deals with angular diameter, not the position.
Yeah.
I don't think you understand what I was saying.
No, this is all fucked up, fucking confused.
What I
I
think
have
he's
no
saying is that
idea.
you can't transform it into an orthographic view.
No,
That's
I don't
right.
think orthographic view has anything to do with it.
Because, listen, if you transformed it into orthographic view, then Polaris would have a height, right? Because if
No.
you knew
That's
the angle and you knew how
That's
far
right.
away you are from the GP, then
That's
Polaris
right.
would have a height. Because you'd have a right triangle, right?
You still have a right triangle. You're just looking at it
Yeah.
at different perspectives.
Yeah.
What does orthographic mean?
It's
Side
not the
view.
vision. You're looking at side view.
Mobile vision.
2D, like a drawing on a piece of paper. That's orthographic.
It doesn't matter with
Like
trigonometry.
an engineering diagram or
Right.
something.
India. It doesn't
Yeah.
matter with trigonometric functions, though. It doesn't matter whether I get a 45-degree angle on a flat piece of paper versus if I measure a 45-degree angle. That makes no fucking difference. It's still a 45.
Well, yeah. I'm just trying to translate. I'm trying to get what he's saying, man. I'm trying to
I'm
figure
not
out.
getting it. Maybe he can explain it to you, and then you translate it to me because I'm not fucking getting it. And by the way, Indio, there's.
I'm not getting it.
Uh,
Yeah, I
Indio.
saw it. I saw it then. I haven't listened to it yet, but I saw it.
Okay, appreciate that. Thank you.
All right.
I've listened to it. It's funny as fuck.
Well, I listened to the first 7 seconds, and that was funny.
I didn't mean it to be funny. I meant it to make a point, or to elucidate more than 4 hours of debate. I shrunk it down to 7 minutes. Good. So go
Yeah,
ahead,
yeah.
Rebel. If you can explain it, Indio, I would like some feedback on that. But whenever
I'm trying to understand it. We're in the same boat
I
here.
want some holy fucking shit! I want some feedback on the audio. I want some feedback on the audio I sent you on this topic with Rebel. Please, the floor is your two guys, and then when you get done, please translate that shit back to me. Okay.
Okay.
And then Content Morose can talk about it later.
I'm not certain what it is you're asking. You're asking me to listen to the audio?
No, he's talking to me about that. These are two separate topics. One is personal between me and him, and the other one is public.
Yeah, doesn't have anything to do with you, Rebel. Don't get fucking paranoid. So just explain your position with this topic, trigonometric functions, and perspective within Indio.
All right, now?
You can, and let's see if he gets it, because I'm not getting it.
Okay. So,
I feel like I'm under pressure.
for the sake of argument, right? Let's say we know the height of the Polaris. And from orthographic perspective, we would know
The angle or height, right? The elevation angle?
the elevation angle. That's right. The length of opposite and the length of the tangent.
You don't know
Meaning-
the length of the opposite. Wait a second. You don't know the length of the opposite yet. You just know the angle.
No, we don't. But we would from orthographic perspective. Mind
No,
you,
you
this is a key point.
Not yet.
No. So at 45 degrees,
I'm gonna
we would.
step out. I'm gonna step out. Just I need to go feed the cat. You and Indio, and then Indio square me up. Thanks.
Your fingers crossed.
So, so imagine you're looking at a piece of paper, and I'll draw a triangle, 90-degree triangle, and the angle of tangent to hypotenuse is 45 degrees. You with me?
Yes, I'm with you.
Okay. So that implies from trigonometric function is that the length of tangent should equal to the length of opposite. The opposite
Okay.
is the line from GP to Polaris.
The base, right?
Yeah, from the well, no.
From
The
you to the
opposite is
GP.
the
hypotenuse.
opposite is the side of a triangle from GP to Polaris. You with me?
Oh, so the hypotenuse of the triangle, right?
No. Hypotenuse is the line that connects the Polaris to your position.
Okay. And okay, so let's just hold on, slow down. Okay, so there's three sides of a triangle. There's
That's right.
my elevation angle. That's me looking at Polaris, that line of sight. And then there's the baseline, which is the line from me to the GP.
That's right.
And then
That's
there's
called
the
the
line
tangent.
that connects the GP to Polaris.
Right. So that one, the last one, is called the opposite.
Yeah.
The line between you and GP is the tangent line.
Yes.
It's a parallel to the ground. That's right. So the line between you and Polaris is hypotenuse.
Yes.
Okay. So now imagine the angle, we'll call it alpha,
Okay.
of between the tangent and hypotenuse is 45 degrees.
Okay.
Now imagine, now remember, we're looking at it from orthographic standpoint on a piece of paper.
All right.
You with me?
Yeah.
Okay. So trigonometric function will tell you, in such a case, the length of tangent, meaning the distance between GP and U, should equal to the length of opposite, which means from GP to Polaris. That's just a fact.
Orthographically, yes.
That's right, on the piece of paper. Now imagine, so okay, that's the intro to the scenario. So now we're on the same page. So imagine that's the scenario, and I'm looking at you from orthographic standpoint. I'm looking at Polaris, at you, and the GP, right? So now, without you changing position, you're not moving anywhere. Polaris not moving anywhere. GP moves nowhere either. Now I'm just zooming in, so to speak. Uh, transforming this scenario into 3D. Okay, so I'm just taking this piece of paper and I'm going into this world, and I'm standing in your position and looking at Polaris. Now you haven't changed the position. Polaris hasn't changed the position. And if I ask you to measure the angle between the horizon to basically elevation angle to Polaris, intuitively is where I made the mistake. You would think that's going to be 45 degrees, except the perspective will play a role in you not having to measure 45 degrees. You understand?
Yeah, I understand, but I don't understand how that would actually. I mean, it's probably like a cognitive bias, quite honestly. Because the way I think of it, right, is like, you can transform 2D into 3D projections and back and forth using like homogeneous coordinates and shit, like 3D graphics.
No, it's a lot simpler. You're overthinking it. So, okay, imagine Polaris is just a light bulb, okay, in a room. Okay? Light bulb in a room.
So you're saying it won't be 45, right? From like if I zoom in to where the observer is.
That's right. It would not be 45.
It would not be 45.
That's right.
What would it be?
It would be less than 45 because of perspective. A lot less than 45. So thinking of the trigonometric functions in orthographic view, when you're looking at a piece of paper, is not the same as when you're looking at the celestial objects, let's put it that way, right? Whether it's a light bulb on the ceiling or Polaris. Those functions have nothing to do with, let's say, reality in terms of the
45.
3D.
Yeah, you're right, because it could be anywhere on that line, and a trigonometric function cuts it off on an arc.
It's not even an arc. It's just because of a perspective, the Polaris will look lower because you're at the distance away from it, right?
Yeah.
Right.
Yeah. I get it, dude. I get it.
So you will never measure 45, even though I placed you at the 45 degrees in orthographic view, right? But when I zoom in to your position in the 3D world, imagine like a 2D piece of paper now morphs into the 3D.
Yeah.
The angle between the horizon and basically elevation angle between the horizon and the object you're looking at, which was 45 in orthographic, will never be 45 because of perspective.
Yes.
Forget
exactly.
the reflections.
Because of perspective. Because so below the eye line, like say it was surface of water, right? That water ramps
not
up.
only that.
Right. Well, just hear me out, right? So the water actually ramps up in your vision, so it can't ever be 45 because that water, right, that goes up to the horizon, that appears to rise to the horizon. Because when we look at the ocean, right, we see water going up to the horizon. That takes up some of the 45. It has to.
So think of it this way. Think of the length of the opposite as a fixed length. Let's say 1 meter. Well, let's make it 1,000 meters, a kilometer. Right? Let's forget about trigonometry altogether. So that length, let's say, imagine that length to be a pole, like a light, street light, which is a kilometer high. Yeah. When it's next to you, right, it's going to be gigantic, right? You're going to look up, you're not going to see the end of it. If I move it away from you, now the length of it shrinks from perspective wise, right?
Yeah, I get it.
Right. So you can never ascertain the height of that pole unless you know the distance. Understand?
Yes. I understand.
So hence, same goes for the elevation angle, because elevation angle will depend on the length of that pole. You understand?
Yeah. I get it.
Right. So 45 degrees in orthographic morphing into, without changing any of the positions of the objects on the 2D paper, right? We have a Polaris, we have a GP, we have U at 45 degrees. If I'm morphing into a 3D world, trigonometric functions cease to exist because now we're looking at it with perspective flaws.
Yeah,
which
that's
means
right.
the
And it's all linear. There is no trigonometric function. It doesn't exist.
That's right. So if you measure, now nobody changed position. Now we're in 3D world. Now I ask you to measure the elevation angle to Polaris. The intuitive thing to say it's 45 degrees, of course, because we just did it on orthographic. But when perspective plays a role, you're going to have a degree which is less than 45.
Yeah, dude, I completely get what you're saying.
There you go. Okay.
I'm just trying.
That's exactly what I'm saying.
Super. I don't want to say it's complex. I would say it's tricky to like conceptualize.
This is what Matthew.
Because I know how to do like perspective projections, right? So like if you go on, we have an optics channel. There's all sorts of videos on how to do perspective projections, right? So if like you draw a circle on the ground, it looks like an oval, right? Because you have a projection plane and a principal point and a horizon line, and like you project all that shit onto a plane, and those angles don't exactly match like the orthographic view. So if you took the orthographic side view of all that, the angles that you measure in that wouldn't be the same as the angles you would measure in the perspective projection. They're not the same. But it's hard to, I would say it's hard to actually communicate exactly how they're different.
Exactly. That's the pitfall. And me being a seasoned flat earther, right? I'm a flat earther since 2015. Right? I was at the Nathan shows since the show, before he had a 100 show. But even as a seasoned flat earther, even I fell into the pitfall of mixing the two, the orthographic trigonometric functions.
Well, here's the funny thing. I've been saying for a long time that it's never been actually demonstrated that perspective is mathematically equivalent to Euclidean 2D space.
Precisely.
Right? There's no mathematical proof of that. It's just assumed that it's true.
Well, they can't.
Like one of those things in math. Well, obviously it's not, but it's like it's just one of those things that in modern mathematics that they just like when they teach
they can't be ephemeral.
I know they can't be. I know they can't be. Like, but they teach it in university and like in mathematics classes that they're basically equivalent, and they're not.
Yeah, right. But my point is, it's such an easy pitfall to fall into, even for
you're falling into a pit that there's no information there. That's the point. There's nothing.
There's a separation between the.
It's not about information. It's about once somebody mentions 90 degree, somebody with a background in mathematics, right? Well, intuitively will think of, trigonometric functions. Yeah.
Yeah.
So that's how we were taught. That's how everything is.
And that's how globe earthers think about the Earth, right? When they ask like,
exactly, and that's what Matthew was pointing out.
Professor Dave's like drawing this disc with people like looking away from each other.
So we have another avenue.
That's why Matthew was saying, now
that this is being elucidated to, I mean, not that we didn't know, we just have a more concise, better way of pointing it out. Whereas we didn't point it out. Well, I guess we do point it out, but
we don't have a good way to point that out.
No, we do. We do, because I just had a debate in Earth Awakenings, and a set of words that I'd never used was easily conveyed about this.
Okay, well, you're saying you've conveyed it better than I did. Okay, good.
Well, it's simple. I mean, you see a pair of train tracks. It's obviously not Euclidean what we see.
Yeah,
I mean,
what I'm saying is,
we don't just say that. Like that's the statement. Nobody has to argue for 5 hours about that. patently obvious.
I mean, Elijah, you heard me argue that before, obviously.
I know, but and we argue about it. But now, instead of giving these these arguments that could go for an hour, 2 hours, I'm only willing to say, well, that's obviously not the case. And if they don't accept what I've said, then it's not a level. I'm not prepared to go down a few levels to make that known.
Often I use the railroad track analogy on people that are like, let's put it this way, simpler, right? They're not familiar with the topic. They're not like anti-flat earthers that try to baffle you with bullshit.
Yeah.
Unfortunately, I fall for this trap too, right? We get stuck in the weeds, right? Arguing the minutia of, angles and trigonometric functions and a bunch of bullshit when all you have to do is talk about railroad tracks, right?
Yeah.
Instead of make the mistake like, oh, I'm going to talk to my audience instead of just going, let's just talk to everybody like they're five.
Mm-hmm. Mm-hmm.
Well, I'm happy to hear it's a very simple concept for you guys. It's not a simple concept for me. It took a while.
It is simple for you. I'm not saying how it was or wasn't in the past. Telling it to you now. I mean, do you disagree that it's obvious based on a pair of railroad tracks?
From a formal mathematical standpoint, it's complex, but from just
it is. Once you pipe out,
experiential standpoint, it's pretty simplistic.
Yeah, the only it's a nuance. It's really nuanced thing. But once it's like a psychology plays part as well. Once you pipe out a term has to do with angles and triangles, the people with mathematical background will instinctively think of orthographic view, right? Because that's exactly how they measure things. That's all the computer science, all the trigonometry.
Of course,
right. Right.
That's why the path is to use a real world example to point out that, hey,
you cannot reconcile.
We need to separate these two.
Exactly. They cannot reconcile the perspective.
No, not unless you elucidate it to them. Are you telling me that once you elucidate this point, it would be still complex for someone to understand? It's a very simple point.
Okay, so I'm glad you've said that. So that's exactly the point.
But you have to say it in order for someone to get it. If you don't say it and you go this long-winded argument where a person is, just thinking, you have to separate it for them.
Can you let me finish? Let me finish.
Why? You're annoying me now at this point. Because it's a waste of conversation. I actually came in here for another reason.
Okay, then you are the Lord. It is hard, and if you think it isn't, you're delusional.
It was hard. It isn't hard anymore. It was hard to think of the Earth as not a globe before. Now it's not. Like, what the fuck's the problem?
We are not talking about that. We're talking about.
Yeah, we are. You just brought up psychology. That's exactly what we're talking about.
No, we're talking about. If you'll have let me finish, you will probably understand what I was talking about.
I heard that. So if I repeat your point, your position now,
but you are
are you going to still say that I need to understand what you have to say?
I cannot finish the sentence, okay? Because you are annoyed.
No.
So where we go from here?
Because I already heard you, and I don't like conversations that are circular. Because you're about to tell me that I didn't understand what you said. You already said it. I gave you a rebuttal. You're going to just repeat what you initially said. I don't want that.
I don't give a fuck what you want. I'm speaking to what is.
Well, why don't you just challenge me to tell the audience what you meant, and then tell me if it's right or wrong? Because instead of us going back, you can kill me right here.
You and I are not in opposite.
I'm sorry. I'm not doing it.
Tags! What is your profession? See, old friend, I brought more soldiers than you did.